Section 7 of Chapter 5, we're moving on to the fundamental theorem of algebra. So that theorem is actually quite simple. The theorem simply says that the degree of the function tells the number of solutions. And I think that I've told you that somewhere in these lessons at some point, and I don't remember exactly when. But the bottom line is, whatever the largest degree, whatever the degree of the function is, that tells you how many solutions you have. So in this function, x to the x cubed minus 5x squared minus 8x plus 48 equals 0, the largest degree, the largest exponent is a 3, so that tells me I need 3 solutions. Now, what you need to know is if there's a squared term, that solution counts twice. So in this case, we have a -3 as a solution, and we have a 4 as a solution. So we just have 2 solutions, but because this x minus 4 is squared, this one counts twice. So we do, in fact, have 3 solutions. So these problems are going to be super easy. The first section of your homework is simply going to say, how many solutions does this function have? And the answer is, all you have to do is look for the largest exponent, and the answer is it has 4 solutions. Do this one for me real quick. How many solutions in this one? Well, the answer is there are 3. 3 solutions. Now, when you find those solutions, let's see. So in this case, you've got we can use grouping to get this one. So x squared, we've got x plus 1 here, and we've got -3, so we've got x plus 1 here. So x squared minus 3 times x plus 1. And in this case, it looks like, well, we just have 2. Well, no, because this x squared term, if you set that equal to 0, so x squared minus 3 equals 0, so you add 3 to both sides, and so the square root of 3, so x equals plus or minus the square root of 3. So your solutions here are -1 and square root of 3 and negative square root of 3. And you can write that as plus or minus the square root of 3. And so that's 2 different solutions. All right? So let's do one great big scary looking one and show you that, oh, it's not so bad. So if I want you to find all of the zeros in this function, how many are you looking for? Well, the answer is easy. There's 5 of them that you're looking for. So let's start by narrowing the field down. What are the factors of 14? Remember, we did this. So the factors of 14 are 1 and 14, 2 and 7, and that's it. So we have the possibility of plus or minus any of these. So we have 8 possible answers, and remember, we can double them also if one of them is squared. So we need 5. All right, so let's see what those are. Let's narrow it down. Let's use synthetic division just like we've done in the last couple of lessons. So we've got 1, we've got -4, we've got +4, 5, 4, 3, 2. Oh, we've got everything 10, -13, -14. And what I want you to do is, if you think you know how to do this, go ahead and pause and you do it and then come back. All right? Did you do it? Did you get 5 answers? Here we go. I'm going to do it because I know what the answers are. I'm not going to go through the whole guess and check and getting them wrong. I'm going to choose the right ones. Okay, here we go. So we're going to use -1. Bring down a 1, -1. Add those together, -5. Multiply and get a +5. Add them together and get a 9. Multiply and get a -9. Add them together and get a 1. Multiply and get a -1. Add them together and get a -14. Multiply and get a +14. And that does indeed cancel out. So -1 is one of your zeros. We need 5. We got 1. So let's divide again because, you know, we can't have the same thing twice. Let's divide again by -1. Bring down a 1, multiply -1. Add those together, -6. Multiply and get a +6. 9 and 6 are 15. Multiply, -15. Add -14, multiply, negative times a negative is a +14, and those cancel out. So -1 is a possible solution, or not is a possible, is one of your solutions. So -1 and -1. So you've got 2 factors of x plus 1. All right, so then did you try 2 after that? Bring down a 1. 1 times 2 is 2. Negative 6 and 2 are negative 4 times 2 is negative 8. What do we bring down here? 9. 8 and 8 are 16. Oh man, what do we got? What do we got? 7, duh. Okay, 2 times 7 is 14, and that cancels out. So 2 is one of our solutions. So now we have x squared minus 4x plus 7. And there is nothing that I can multiply together. 7 and 1 are my factors of 7, and you can't add those together to get 4. So you've got to use the quadratic formula, which you know how to do. So here we go. Negative b is a positive 4 plus or minus the square root of b squared is 16. Minus 4 times a is 4 times c is 7. So, and that's over 2a, which is just 2. All right, so 4 plus or minus the square root of 4 times 7 is 28. So 16 minus 28 is a negative 12 over 2. And negative 12, you'll see that it's negative. Aha. So 4 plus or minus, we can take out, let's see, this is the same as 4 times 3. And 4 is a perfect square. So this is 2i times the square root of 3. If you didn't know, if you can't see where I got that, then back it up and look again. Because 4 times 3, the square root of 4 is 2. And the square root of a negative 1 is I. And 3 is what's left. All over 2, we can reduce down because we've got factors of 2 in both of these. So we end up with 2 plus or minus I square root of 3. So we do end up with negative 1, 2, and 2 plus or minus I square root of 3. Those are our 1, 2, 3, 4, 5 solutions because this is plus or minus. So these are our 5 solutions. Now what I want you to do is, I want to show you the graph of this function, and I want to show you some specific things. One thing is that the only zeros that are shown are real numbers. Well, that kind of makes sense, right? Because you can't have imaginary numbers on a real graph, right? So the imaginary numbers are not going to show up on your graph. So if you were to graph this function and say, oh, I'll just graph it and then I can get my zeros that way. Well, you can, but you're not going to get all 5 of them because 2 of them are imaginary. So you're only going to get the zeros that are real. And now if you'll look, this negative 1, because it shows up twice, it only shows up once on our graph. You can't cross twice in the same spot. So here are the things that you need to get into your notes. Here are the important things. Only real zeros are on the graph, not imaginary ones. All right, get this into your notes. Only the real zeros are on the graph. If you have an odd number of factors, so in this case we just have 1, 2. That's an odd number. If there's an odd number of the same factor, so the 2, there's only one of them, then it crosses the x-axis. And you can see here that at 2, the graph crosses over. Okay? So if there's an odd number, so if you were to end up with 3 factors of the 2, it's still going to cross. But if it has an even number of the same factor, then it's tangent to the x-axis. And tangent means that it comes right up next to it and touches it and then turns away. So you can see here that at the -1 point, it's tangent. It touches it, but it doesn't cross. All right? So if you've got an even number of factors, so if you've got a squared term somewhere in your solutions, then at that point in your graph, it's going to just be tangent to your x-axis. That's going to be a turning point, either a minimum or a maximum. All right? Those are the important things. One other thing that you need to know is that if you have an imaginary number, you're going to end up with 2 imaginary numbers. So if you have a plus bi, if a plus bi, so if 1 Oh, crash. If one imaginary number is on your is a solution, is a 0, then you also have a minus bi just by default. So it has to be a plus or minus bi. So you need to know if you've got one, you've got you have the other also. So the reason that's going to come in handy is because I'm going to give you several zeros, and I'm going to have you write equations from them. This will be the last thing we do today. You can do it. Here we go. So I want you to write a function of least degree. So this means you're not going to add more, just do the very minimum that you can do here with what I give you. Write a function of least degree that has rational coefficients and a leading coefficient of 1. And I've given you two zeros. 2 and negative 2 minus 5i are two of the zeros. So what you need to do is you need to remember, first of all, I've given you negative 2 minus 5i as one of the zeros. So you can automatically assume that negative 2 plus 5i also has to be a 0 because of the rule I just told you. If you've got a plus bi, you also have to have a minus bi on your graph. So we actually have we've got 3 zeros here. 2 of them are imaginary, but we do have 3 zeros. So in order to take those 3 zeros and put them into a graph, you need to remember the format that we used for the x-intercept, form of a function. And this is going to work for polynomials as well as just for quadratics that we did before. So the form is, remember it was y equals a times x minus p times x minus q. Remember that? It's the same thing except that now we have more than just 2 intercepts. So we're going to put it into that same format. So y equals a times x minus 2. And we have x minus, here let's do x minus negative 2 minus 5i, oh man, and x minus negative 2 plus 5i. Oh, okay. So, and we're not going to have the a. We're just going to do it like this for now because I didn't give you another point. Later we'll do that part. All right, so now we still have the x minus 2, and we're just going to, once you plug in the your zeros, now you just have to make it look nicer. Just simplify it. So we're going to multiply this negative through here. So we've got x plus 2 plus 5i, and we've got x plus 2 minus 5i. Okay, now what I would do in this case is multiply your trinomials first and then multiply your binomial. So we just have to multiply it out until we end up with just one polynomial instead of all these polynomials multiplied by each other. So use your extended FOIL. So x times x is x squared plus 2x minus 5xi. Whew, all right. And then our 2's plus 2x. And what I would do here is I would stack these so that you're not having to, because they're going to have all sorts of different terms. Let's put the terms together. So this is going to be 2x plus another 2x here. And then this is going to be 2 times 2 is 4. That doesn't match here, so we're going to put it over here. And then 2 times negative 5i is going to be negative 10i. And now we're going to have 5i times x is plus 5xi. Now do you see why I did that? And now 5 times 2x is going to be, 5 times 2i is 10i. There we go, plus 10i. And this is going to be 5i times a negative 5i is going to be negative 25i squared. Whew. All of this stuff. Now we're going to combine the like terms. So x squared plus 4x. These two terms thankfully drop out because xi, wow, yuck, but that's okay. We could do it if we have to, but it drops out. And also this negative and positive 10i, those drop out. So we have plus 4 minus a 25i squared. Remember that I squared is the same as negative 1. So we've got a negative 25 times a negative 1 makes this plus 25. So simplifying it one more step, x squared plus 4x plus 29 is our final function. X squared plus 4x plus 29 equals our function that includes these zeros. So this is going to be the function that has the zeros at those three spots. So there we go, x squared plus 4x plus 29. So put in your zeros, so x minus the zeros. And if you'll remember this is really going backwards from what we did. We started here and we divided out until we got factors. So we're just starting with the factors now, and we're going to multiply down until we get the function that we started with originally. All right? And the reason we don't have the a is because we want the leading coefficient to be 1, and so that's why we didn't need to deal with that. Get something to look forward to. We'll do that later. All right. See you later.